The Arctic is changing dramatically. The polar ice cap is shrinking. This is giving greater access to the Arctic, but it's about more than just open water. These newly melted floes mean increased access for shipping, tourism, and natural resource exploration. All this will likely increase demands for search and rescue. As nations ramp up activity, the Arctic is quickly becoming a contested expanse. The U.S. and others are looking for ways to protect and responsibly manage Arctic economic development. In 2013, the White House released the U.S. strategy for the Arctic. The Coast Guard followed with their revised Arctic strategies. The Navy is doing the same. Every report has a consistent concern: the ability to communicate. In a region mostly devoid of infrastructure and cell phone towers, users are looking to the sky for a solution. While most geosynchronous communication satellites don't cover the Arctic, the United States Navy Mobile User Objective System, or MUOS, is showing that it can. Not just simple voice communications, but secure, prioritized voice and data connections that work on the move. That's because MUOS uses a different kind of waveform called WCDMA. It's technology everyone uses on smartphones, streaming voice and data, but it's never been used for secure communications, and never before used like this in the Arctic.
We're in Barrow, Alaska, getting ready to test MUOS at the most northern reaches of the planet. We're going to take a C-130 and fly to the North Pole and test the MUOS signal all along the way. MUOS is a geosynchronous satellite, so it's roughly speaking at the equator. And as we get farther and farther from it, it's going to look lower and lower in the sky to us. Somewhere just before the equator, it's going to dip down below the edge of the world. We theoretically won't see it anymore. But UHF radio signals, they actually propagate and curve a little bit, and so we actually think we'll be able to get signals really close to the pole. MUOS isn't required to perform above 65 degrees north. That's right around here, Fairbanks, Alaska. But it does, and we've been demonstrating that the WCDMA signal works much better than the legacy signal. MUOS is ideal to compare performance since the satellite has both a high-speed voice and data WCDMA payload as well as a legacy payload that's mostly used for voice communications. This allows us to simultaneously compare the effective waveforms given identical environmental conditions. The MUOS signal isn't just an aerial asset. Terminal users have just as good a connection on the ground, sending voice and data even while on the move.
Let's go ahead and power on.
We exceeded even our own high expectations. That's a lot of additional capability for the same price. We're not done testing yet, but these experiments suggest tremendous operational benefits in a growing and important mission area. An additional feature of a geosynchronous constellation is the Antarctic should see similar benefits. What it all comes down to is Lockheed Martin delivering capability that users really need.